The question says that at what angle should a ray of light be incident on the face of a prism of refraction angle 60 degrees so that it suffers total internal reflection at the other face? The refractive index of the material of the prism is 1.524. So here we are being talked about the faces of prism A, B, C, and the faces that are in consideration are AB and AC. Now, on the face AB, the incident ray ON makes an angle I of incidence with the normal, and it goes in the prism with the angle of diffraction equals to R1. Now, it strikes the second face AC with an angle of incidence of R2, and it goes out with an angle of refraction as E, or angle of emergence. Now, in our question, it is said that on the second phase, it should reflect such that total internal reflection happens, or the angle of emergence should be equal to 90 degrees. So, for that condition, we have to find out what would be the value of I. So, we know in a prism, the angle between two faces are called the angle of refraction. The prism, and it is given over here that it is 60 degree. So we also know the relation for prism that R1 plus R2, this R1 plus this R2 is equals to the angle of refraction of the prism, the angle between the two faces, and that would be equal to 60 degree over here. So R1 plus R2 equals to 60 degree. Now we will be applying Snell's law on these two faces AB and AC. So applying Snell's law on face AB, it would be equal to, if the outer media is having refractive index of mu1 and the prism is having refractive index of mu2, then it would be equal to mu1 sine I is equals to mu2 sine R1. So we can say that the mu1, or the refractive index of the media surrounding the prism is 1, and sine I would be equal to 1.524 times sine R1. Now applying Snell's law on the interface AC, that is the second phase, we could see that it is mu2 sine R2 equals to N1 sine E. N1 is the refractive index of the media that is surrounding the prism. Now for total internal reflection, as we discussed, E would be equal to 90 degree. So substituting the value, we will get sine R2 equals to 1 by 1.524. Now R2 would be equal to sine inverse of 1 by 1.524. This will give us R2 the value of 41 degree. Now substituting this value R2 equals to 41 degree in equation number 1, that was R1 plus R2 equals to 60 degree. We will get the value of R1 as 19 degree. Now substituting this value of R1 as 19 degree in equation number 2, we will get the value of I. So solving for the value of I, we will get the value of I as 30 degree. Thus, for the angle of incidence of 30 degree, we will get the total internal reflection on the second face of the prism. Thank you.